Hey guys, today we're going to talk about complex numbers. This should be a review for you, and we're going to take it a little bit to the next level, but in general, you should have seen this before. So let's go back and talk about complex numbers. Remember that a complex number has this form a plus bi, where a is the real component and b, which is a real number, times the I, which is the imaginary number. So again, this is the real component, and this is the imaginary component. That this is in complex standard form. So remember, anytime you have a complex number where you have a real part and an imaginary part, the imaginary number goes last. And then lastly, when we're talking about complex, remember a complex number is a plus bi, and a conjugate is when they have the same terms but opposite sign in the middle. That if you've got some complex number, its complex conjugate is the same terms but the opposite sign in the middle. All right, let's talk about I, and hopefully you remember what I is. But I is defined as the root of -1 because no real number squared is 1, right? Because I should say -1, right? So because no number squared can be -1, we know that I, we call, is the root of -1. And by definition, I squared is like saying -1 squared, which the square and the square root cancel each other out. So the I squared is just -1. Keep that in mind. We're going to want to keep that for later. For the complex number, a plus bi, if b equals 0, so think about that. If a plus bi were b equals 0, well, 0 times I is just 0. So that would just give us a real number, okay? If b doesn't equal 0, if it's a value, the number a plus bi is a complex number. And if a equals 0, that would be 0 plus bi, where that is just simply an imaginary number alone. And the set of complex numbers, back up. The set of complex numbers consists of the set of the real numbers and the set of imaginary numbers. So basically, we're just establishing that a complex number is any value of a real number plus any imaginary number. So two complex numbers, back up. Two complex numbers, a plus bi and c plus di, written in standard form, are equal to each other if a and c equal to each other and b and d are equal to each other. To add two complex numbers, you're just going to combine both real parts, and then you're going to combine the imaginary parts. I-M-A-G-I-N-A-R, the imaginary parts. To subtract them, you're just going to subtract the real parts, then subtract the imaginary parts. I cannot spell imaginary today. And then we're not going to worry about that. Let's talk about how to perform this operation. So if I've got this expression here, 5 minus 6i minus 3 minus 2i plus 4i. Keep in mind this minus, we're going to distribute it to both. So we're going to make this an opposite, opposite, opposite. And what we get here, we get 5 minus 6i, let me make this a little smaller, plus -3 plus 2i plus 4. And now we're going to combine our like terms. So we've got 5 and -3 are like terms. 5 minus 3 is just 2. And then we've got -6i, positive 2i, and positive 4i. If we combine those like terms, we get negative 6i plus 2i is negative 4i plus 4i is 0i. Well, 0i is just 0, so 2 plus 0 is 2. Okay? If you're going to multiply complex numbers, all you need to do is FOIL, then simplify and combine. Or combine and then simplify. So for example, if I'm multiplying this, if we're going to FOIL this, just pretend for now that I is just a variable. So we're going to go first term means the 5 and the 3. 5 times 3 is 15. The outside term is 5 times negative 2i. So 5 times negative 2i is 10i. I stands for the inside terms. Negative 6i times 3 is negative 18i. And our last terms are negative 6i and negative 2i. That's a positive 12i squared. Now remember, what did we say about I squared? I squared is really a negative 1. So this is really 15 minus 10i minus 18i plus 12 times negative 1, which that's just a negative 12. So now we're going to combine like terms and simplify. So I know 15 and negative 12 is 3, and negative 10i and negative 18i is negative 20i when combined. And that is our total complex number. Let's talk about complex conjugates. The product of a pair of complex conjugates is going to be a real number. So if you multiply them out, you're going to eliminate whatever I is. To find the quotient of, so remember quotient means division, the complex conjugate quotient of these two numbers, you're going to multiply both the numerator and denominator by the complex conjugate of the denominator. And we'll talk about that. So for example, if I've got 1 plus I over 2 minus I need to simplify this. I can't have this I in the denominator because technically it's a root of a negative. So I'm going to multiply both top and the bottom by the complex conjugate of the denominator. So do you see how they both have 2 and I? This is a negative, so therefore my complex conjugate had a positive in the middle. And now we're going to FOIL the top and the bottom. So here we go. Let's do this. So we go first, 1 times 2 is 2. Outer, 1 times I is I. Inner, 2 times I is 2i. And last is I squared. We'll leave it just like that for now. And then we're going to FOIL the bottom as well. 2 times 2 is 4. 2 times I is positive 2i. Negative I times 2 is negative 2i. And negative I times I is negative I squared. Now let's simplify what we've got. Let's do the denominator first. See how we've got 2i and negative 2i? Those will cancel each other out to 0. And we know I squared is really negative 1. So if I've got 4 minus negative 1, that's really a positive 1. So in the denominator, we have 4 plus 1 is 5. Let's simplify the top now. Again, I squared is really negative 1. So our real terms here are 2 minus 1 is 1. And then I and 2i is 3i. And we can leave it just like that because I can have an I in the numerator, but not the denominator. And then lastly, our complex solutions of a quadratic equation. So for example, if I end up with a solution of the root of negative 7, this is not a real number. We know this, right? Normally we can't take a root of a negative number, but if you factor out I, where I is equal to negative 1, you can write the number in standard complex form. Remember, which is a plus b I, where you can factor out that I value. So if you've got the root of a negative a, that's exactly the same as saying the root of a times I, because we factored out a negative and turned that into I. All right, that's it for today. See you in class.